Dzień dobry, Kraków! Jestem Dave Aronson I przyjechałem opowiedzieć wam o Acrumen. Ale zrobię to po angielsku. Mainly because you've now heard about half the Polish I speak. But first, you may be wondering, who is this Dave Aronson guy? Why should we listen to him? Well, I'm a developer, like most of you, with about 3.5 decades of experience. For the past several years, I've been the T-Rex, yes, really, of Codosaurus LLC, my little one-person consultancy, which explains how I can get such a cool title. I'm also a member of TopTal, a consulting network of senior-level developers, designers, and so forth. And I'm a member of their speakers network, which told me about this conference and helped me prepare and practice this presentation. But I am not speaking on their behalf. I'm the only one to blame for these crazy ideas, despite my secret identity. So feel free to ask me about them later, and please do use my referral link if you want to try to join us or hire us. But if you don't like the ideas, just blame me. So speaking of these crazy ideas, let's start looking at Acrumen and start with a poll. A question. Give me a loud cheer if you like low-quality software. I hear a few people there. Well, we might be able to help you with that. But more importantly, give me a loud cheer if you've written any low-quality software. That's more like it. Yeah, I know, I sure have. So it seems pretty clear to me we need more software quality. But that just leads us to one tiny little question. What is it? If we don't have a good definition, we can hardly hope to advance even our own software quality, let alone the whole state of the art. There have been some previous attempts to define software quality, but they were mostly, if not totally, from the point of view of only us developers, and resulted in long lists of complicated terms full of jargon. So to make it understandable to other people, I zoomed out from down in the weeds where we developers tend to live, up past the 10,000 meter view to about low Earth orbit. And that let me pare it down to just 6 aspects and take into account not only the developer point of view, but also many other stakeholders, like the users who will be using our software, the customers who will be paying for it, or not necessarily the same people, and our management and QA and tech support and other colleagues. And I call this set of 6 aspects Acrumen. So what does that mean? Originally, it was a Latin word meaning sour fruit, like grapefruits and limes and especially lemons. So I'm taking those sour lemons that life hands us, often by the bushelful, and making what I hope will be delicious lemonade in the form of the Acrumen Software Quality Framework. Which brings us to the question, what is that? Mainly, it is the acronym Acrumen, try saying that 10 times fast, which takes those aspects and puts them in priority order. And those aspects are, at long last, that software should be appropriate, correct, robust, usable, maintainable, and efficient. But what does even all that mean? As you may have guessed from the amount of space there, I'm going to go into a little more detail, and then I'm going to go into a lot more detail on each one in turn. Most importantly, it needs to be doing what the stakeholders need it to do. In other words, doing the right job. Once that job has been identified, it needs to be doing that job correctly. In other words, do the job right. I know those are linguistically close enough to be a little confusing, but I'm hoping the parts in parentheses will help you out. Then it needs to be difficult to make the software misbehave. And in particular, I'm going to define what it means to behave. But it needs to be easy for the users to use and for the developers to change. The other way around, not so much. And last, dead last, despite how we developers tend to really worship this, it must make efficient use of resources. Now, I've said a few times there are 6 aspects, but Acrumen has 7 letters. So anybody want to guess what the N stands for? Well, don't worry about it too much because it stands for nothing. I just tacked it on to make a real word. Now, before we go any further, I've made a special treat just for DevConf Poland. Aspekty po polsku. Oprogramowanie powinno być właściwe, poprawne, odporne, praktyczne, utrzymywane I wydajne. And that was the other half. So no, I'm not going to try to pronounce the rest of that. And many thanks to the fine folks in the Poland channel of the TopTal Slack group for helping me fine-tune the wording and pronunciation. So now we've got a list of aspects and a little bit of explanation. So what? How do we use Acrumen? Mainly we can keep it in mind as sort of a mental checklist when writing or evaluating software. We can ask, for instance, is it appropriate, at least enough for our purposes? And if not, what can be done to make it so? Now we can look at the details. The first one is appropriateness. If our software doesn't have this, then nothing else matters. If our software is doing the wrong job, it doesn't matter how well it's doing the wrong job. And yet, we developers are generally not taught that this is even an existing concept, let alone one that we need to be taking into account. So it seems to me that it's not only more important than any one of the others, but more important than all of the rest of them put together. And let's try a little thought experiment to illustrate that. Suppose you want a program to play checkers, or for those of you who speak British English, drafts. And I write for you the world's greatest chess playing program. Now, it's as correct, robust, usable, maintainable, and efficient as anyone could ever possibly want. But do you think you're going to be happy with it? Let me hear you. I'm hearing a lot of... but why not? It's such a great program. The answer, of course, is it's not checkers. It's not what you asked for. Or in Acronym terms, it's not appropriate. So now that we have some idea how important it is, how do we achieve it? In an ideal world, we could bring in the experts, which in this case would be requirements analysts. But on this planet, we generally don't have that luxury, at least outside of working for huge companies. But we can use some of their approaches, mainly, hearkening back to one of yesterday's talks, go talk to the stakeholders, ask them what they want, break it down into small pieces. We developers are generally good at that. And we can go a step further and ask them why they want various things. That will help us get a much better handle on what they really need, which is what we need to satisfy. Once we've got a decent grasp of that, we can show them mock-ups and prototypes of what we intend to do and demos of what we have done. This will give them an opportunity to correct our misimpressions of their needs before we go too far down the wrong rabbit hole. Have any of you been there wasting time implementing the wrong thing? Okay, I guess you have, but it's okay. You can admit it or not. Anyway, there's another thing that we will be returning to over and over in this presentation. We can propose tests. And in particular, I recommend the given, when, then format. which is given these preconditions, when this happens, usually some form of user input, then these are the results, usually something the user can see or otherwise verify. This makes a great link between the worlds of business and technology because they can usually understand it pretty easily, and we can usually turn it into an actual test. Which brings us to the next aspect of correctness. If our software doesn't have this, then by definition it has errors, or more colloquially, bugs. It could be doing its job incorrectly or failing to do the job at all. Now, nothing can actually stop us from writing code that has bugs. But as long as the bugs don't make it into production, it's not that big a deal. Though, of course, the earlier we catch them, the better. So the real question is, just like the thermos, or for those of you speaking British English, the Dewar flask, it keeps hot things hot and cold things cold, but how does it know? Similarly, how do we know that that our code is correct? Of course, the main answer is tests. They prove, more or less, whether or not our code is correct, assuming, of course, that the tests themselves are correct. Even then, that's not quite true, but I'll get to that in a moment. Ideally, our tests are automated, which makes them more reliable, more repeatable, and cheaper than manual tests. And of benefit to us, it makes them faster to get us feedback while the problem at hand is still fresh in our minds. Again, assuming our tests are reasonably efficient. We can start with the tests that the stakeholders agreed to for the sake of appropriateness. These are likely to be high-level tests, like end-to-end system tests and some feature tests. But we should also add some low-level tests, like unit tests and integration tests. Even then, though, normal tests like that we wrote to test specific cases can only prove the correctness of cases that we thought to test. There are some advanced techniques, like property-based testing and mutation testing, that will let the system come up with its own test cases. In property testing, you assert some property about your system, and the system will come up with a bunch of data to throw at it and see if it ever violates those properties you declared. In mutation testing, it will tweak your code, change an and to an or, plus to a minus, things like that. And then your tests should fail. If they still pass, then that's informing you that your tests aren't doing what you think it's doing. Next, we get to the first of the three rather fuzzy aspects, which is robustness. If our software doesn't have this, then it may simply just show a lot of error messages or other signs of weakness, or it may crash a lot or even get hacked, because robustness includes security. The short explanation is that it's hard to make the software misbehave, but what does that even mean? There are a few other concepts, but most of what I mean is covered by a core concept of information security, the CIA triad. No, it's nothing to do with spies and gangsters. It's this triangle here of confidentiality, integrity, and availability. So, robust software does not reveal information when it's not supposed to, alter information when it's not supposed to, or become unavailable when it's not supposed to. Now, some would also say it should not become available when it's not supposed to, but so long as it doesn't violate any of the other two parts of the triangle, that's usually not that big a deal. Anyway, a robust system should uphold these principles even if someone is trying to force it to violate them. So, pretty tall order. How do we achieve all that? Once again, we could bring in the experts. In this case, that would be penetration testers, or for short, pen testers. The good news is you don't have to work for a huge company to use them. Many work for small, independent computer security companies that you can hire on a contractual basis. They're very good for testing entire corporate networks or very large or sensitive systems, especially security systems. The bad news, though, is they're probably overkill for most of the projects that most of us will ever work on. They tend to be rather expensive, and they can be rather disruptive because they have to test in the production system rather than staging, let alone development. And they're usually brought in after the system is complete, or at least we think it's complete, rather than being an ongoing part of the process. But once again, we can use many of their tools, especially software, such as static analyzers that simulate the execution of the program, fuzzers that test your program's reaction to various kinds of invalid inputs, and probes that test your system for vulnerability to specific attacks. Many of these tools are available as open source. But even if you have a company that is afraid of open source or doesn't want you to bring in what could be interpreted as hacking tools, then we can still go a long way with their mindset again. And the main part of this is to ask ourselves, what could go wrong? For instance, if the system wants the user to pick a file name, they could type the file name wrong, or pick a file they don't have access to. There may even be external factors like losing the power or the network connection. We should take into account what happens then. But to make it really robust, we have to make it secure, which means we have to think like an attacker. We have to ask ourselves, what are the system's weak points? What can an attacker do that will get them just one step closer to their goals? And in what unusual ways can someone get information out of or into our system? Once we've run out of answers to those questions, for everything we've listed, we must now handle it. Yes, I know that's extremely vague, but how to handle something will vary enormously depending upon exactly what it is. If the user typed a bad file name, we can just ask them for another one, no problem. But if the system detects that there's an attack in progress and data may be getting corrupted, the proper response may well be to shut the entire system down. Obviously much more drastic. But whatever response we decide on, we must now test it because it is an important part of our system. Our next aspect is usability. If our software doesn't have this, then our users could get frustrated and possibly stop using our software if they have a choice. That could be disastrous if the company we are working for is a software vendor or a software as a service or SaaS company. And this aspect is even fuzzier because now we're dealing much more with human subjectivity, plus we're sort of redefining a word. If we Google software usability, we'll mostly find things about making sure that people with various physical challenges can use our software about as well as the rest of us. In other words, accessibility. Now that's a very good goal in and of itself, but I'm adding on a couple more requirements. Mainly that it be easy for everyone to use, not just equally difficult. So to start defining it in more depth, it should be clear at all times what the user can do, should do, and especially must do, and how they can do it, and what else the system can do for them, including any help utilities. And all of that should be easy to do despite whatever challenges the user may be facing. We can start with some of the difficulties that accessibility usually addresses, like little to no vision or color vision, a challenge I have myself, or hearing or fine motor control with which to use a trackpad or a mouse. But there are other things that we should also take into account. The user may be lacking somewhat in literacy, at least in our character set, such as if I tried to use an interface in Japanese. They may even be of low intelligence. Yes, we may joke from time to time about stupid users, but statistically, about half of them will be below average. There may also be external factors. Imagine using a mobile app that we've written on a small phone while the user is standing up in the middle of a crowded bus in downtown rush hour traffic. Accurate tapping is just not going to happen. Another often overlooked part of usability is that all software needs to be usable, whether it's a web application, a mobile application, a desktop GUI application, or even a desktop command line application. Yes, some of us remember those. And also APIs need to be usable, whether they function by means of function calls and such, or a wire protocol, whether it's binary or textual based. So, again, quite a lot to do. How do we achieve all that? Once again, we can, of course, call in the experts. But in this case, we have to remember we're redefining the word. If we call in a usability expert, we're most likely to get someone focusing on accessibility. But the good news is we have a wide range of professions that can help us quite a lot with this. There are people who are specifically user interface or user experience experts that have mostly what we're after. Chances are pretty good that your company, if you're working on a web application, they employ web designers. Even an old-fashioned print graphic designer will have some training in principles and guidelines that will help the user interface look organized and clear. Sometimes, though, we still have to go it alone. And just like with the pen testers, we can go a long way with some of their principles and guidelines. For instance, here we see applying the KISS principle. Keep it simple, stupid. Or if you don't want to be so negative, keep it super simple. Note the simplicity of these two stereotypical apps from two highly successful companies with strong reputations for simple ease of use. And then the cluttered mess from your company, which is probably not something as successful as Apple or Google. Now, you may have some Apple or Google employees or employees of other such successful companies here, but chances are rather few. If the software is something we can use ourselves, then certainly do so. Or as we say in the USA, eat our own dog food or dog food it. But remember, if we find our software easy to use, that doesn't mean that our users will. We have inside knowledge that's going to make it a lot easier. But if there's anything that we found difficult or unclear, it'll be even worse for our users. So yes, dog food it, but mainly to find the pain points. And lastly, it may not be as definable and quantifiable as something like correct functionality, but a good user interface can still be tested. We can bring in some of our stereotypical users, maybe even ones that don't already know our system, and have them accomplish typical tasks. That's what's going on in that room back there, while people in the darker room are watching through cameras and replications of the screen. You can watch for signs on the faces and on the screens of frustration and confusion, or if we're lucky, happiness and exploration. Afterwards, ask them, what did they find difficult or easy, unclear or obvious? Fix the pain points, do more of the good parts, and lather, rinse, repeat. And now we have the last of the fuzzy aspects, maintainability. if our software doesn't have this, then changes take longer and are more likely to introduce bugs and developer headaches. This could cost the company money from delays and cost them key personnel who quit in frustration. We'd probably all agree that the basic concept is that it's easy to change, but I'm going to add some more requirements, mainly that it's easy to change with low chance of error and low fear of error, even for a novice programmer who is new to our team. So how do we do that? For better or worse, the vast majority of software engineering advice is aimed squarely at this. So I'll just pick two basic concepts that go together pretty well and our old standby. First up is good names. You may have heard that there are only two hard things in computer science: cache invalidation, naming things, and off by one errors. Though it sounds simple, naming things is obviously hard given the number of bad names out there, but it's very important. If we give something a vague or worse yet, a misleading name, then the next poor soul to have to work on that software, who may be us, will have to spend a lot of their mental energy figuring out and then remembering what name in the code corresponds to what concept out in the real world domain or elsewhere in the code. So don't inflict that on them or us. Do the extra typing and call something, for instance, a subscription rather than a sub, which could be a subtraction, a submarine, a subdural hematoma, who knows. The next principle is the single responsibility principle. Just like a command line utility under Unix, each thing in our code should do precisely one thing and ideally do it well. If it's doing multiple things, then not only does that reduce the chance that it's doing any of them well, but it's harder to reason about because any usage or change may have to juggle multiple priorities, which could be in conflict. Now, there's not much you can do to easily fix it, but how do you know when it's being violated? One way is to go back to the prior principle. Try to give it a good name, ideally one word, 3, maybe 5 at most. If it's hard to give it a good short name, or that word has to, that name has to include the word and, then chances are it's violating the single responsibility principle and should be broken up into smaller pieces, one per responsibility. Last, we have our good old friend, testing. Writing a test for whatever it is you're doing, like adding a feature, fixing a bug, whatever, will obviously reduce the chance of errors making it into your production code base. But in addition to that, all our prior tests become a regression test suite that should catch anything we break accidentally that used to work. Just knowing that will let us proceed at a quick pace with a clear and focused mind rather than creeping along very slowly and carefully because we're terrified that we might break something and not discover it until the users start complaining. And that is why I mentioned fear at all. For our final aspect, software should make efficient use of resources. If we don't have this, then our programs may run slowly, may cause other programs to run slowly in a shared environment, or could even crash the machine by running out of memory or disk space. So how do we do that? There are lots of different things in this, but I'm going to focus mainly on fixing slowness. I'm sure we've all had programs run slowly, and we look at the source code and find some spot, I think that's where it's inefficient, and spend hours, maybe days, optimizing that little piece, and we confidently run it again, and it's still slow. Anybody have that happen? Yeah, I'm seeing a lot of nods and hands out there. So don't do that. Measure it instead. There are profilers and network capture programs and whatnot that will tell us exactly when, or at least where, exactly where or at least when our program is using too much CPU or RAM or network bandwidth and so forth. But once we've found where it's slow, especially in the case of CPU, why is it slow? Certain kinds of programs tend to have certain kinds of problems. For instance, a distributed system may have too much communication going on, or it could be over a slow network. A database-driven application may have an inefficient query, such as the infamous N+1 problem, or it may be using a bad data model, trying to shoehorn something into a relational model that's better suited for a document store, or vice versa. But in the general case, the usual cause of using too much CPU is a bad algorithm. It could be that we're using something that gets worse and worse the more inputs you have, such as with quadratic or exponential runtime, when there might be something that only takes the same amount of time, linear runtime, or might get better and better per unit at least over time, such as a root or logarithmic runtime. Or it could be we're using a bad data structure that is forcing us into using the wrong algorithm. In any case, we need to be familiar with the normal basic assortment of algorithms and data structures to choose the right one. Now, some of you may be thinking, especially those of you with computer science degrees, well, yeah, I learned all that in school, but there are a lot of self-taught and boot camp taught programmers out there who may be perfectly good programmers, but until they've had several years of real-world experience, algorithmic complexity and things like that is one of the things they tend to miss. So if you've got a degree, be patient with the others, and if you're one of those others, learn this sort of thing. It's not just highfalutin theory, it has immediate practical application. And once we've found out where it's slow and fixed it, we can slap a performance test around it. You know, I had to mention testing eventually, to make sure we don't have that kind of regression. And also, there are some times when we want to use more of one resource to spare some of another. The typical instance is using a little more memory to store the results of an expensive computation that we don't have to do over and over again, or a large item that we would otherwise have to fetch either from disk or, worse yet, from another system, such as a database. But sometimes we want to use actually more memory and more CPU to do things in parallel to save non-technical resources such as user patience. For instance, suppose we have a web application that generates a report. The user can read it there online or download it in PDF, but the PDF takes a few minutes to generate. We don't want to make the user sit through that. So we can take the PDF generation requests, put them in a queue, and let a worker process generate the PDFs in the background. If we have the user's email address, we can just email them the PDF and save our resource of disk space. Now, that was the last aspect, so I'm going to just briefly answer a frequently asked question: what inspired me to come up with this? One of the things we consultants are often advised to do is teach, but teaching common things like most of the languages I know would put me in direct competition with the universities and boot camps and free online resources. So what else should I teach? And that got me thinking, well, why is this knight in shining armor different from all other knights? The main thing I came up with was how to write high-quality code. There's certainly a need for that, but what does it even mean? So I set out to find a definition. Didn't find anything commonly accepted, of course, nor anything I really liked, so I decided I might as well make my own. I came up with a list of aspects, including the ones now in Acrumen, plus S for secure. In the fine tradition of our industry, I started to bring on the acronyms. I tried arranging them into things like you scream with silly marketing fluff like, do you scream at your software? And care some, because you should care some about the quality of your software. I couldn't just put them in priority order because acrosum and axrum just aren't pronounceable. And of course, that's very important. But then I realized that secure was really part of robust. So that got me to Acronym, which it turns out is a fairly common username on a lot of systems. So I looked for words or phrases that had those letters in that order and found Acrumen. And the rest, I hope, will be history. So in conclusion, if we keep the acronym Acrumen in mind as a mental checklist to make sure that our software is appropriate, correct, robust, usable, maintainable, and efficient, then nobody should have cause to be sour about the fruits of our labors. And just to keep things legal, there's all the image credits. No, I don't expect you to read those. And now it's your turn. If you have any questions, I'll take them now. We have about 13 minutes. And later on, you can give me feedback about the concept or the presentation. And my contact information is up there, along with one last shout out to TopTal. And of course, I'll be around the rest of the conference. So, any questions? Well, I guess everything was perfectly crystal clear. Either that or you're too confused to have a question. Anything? Going once? Going twice? All right, you get to get out a little early. Thank you.